Good morning everyone, and welcome to today's worked exam answer video. Today I'm taking a look at a KC calculation which is covered in the AS part of the AQA specification and also appears on the OCR specifications as well. In this particular question, we're being asked to calculate some equilibrium moles, and I'll show you how to lay that out in what I believe to be a very clear, concise, easy to follow format. We're being asked to write a KC expression, and then the reason I chose this specific question is because we're then having to do a bit of a rearrangement of said KC expression, not to work out a value of KC as we perhaps normally might, but to determine the amount in moles of one of the substances from the reaction in the equilibrium mixture. So we're going to have to rearrange it to make the concentration of the NaCl the subject, and then once we've got the equilibrium concentration, remember to do the final step that lots of students miss, which is to determine the amount in moles. As always, I'll go through now and highlight some of the key points and make some annotations, and then I will explain all of my worked answers to you guys. Okay, so we're told that nitrogen monoxide reacts with chlorine to form nitrosyl chloride, the NaCl. Then we're given our balanced chemical equation for this reversible reaction there. So I'm using green for the NO, turquoise for the Cl2, and then the deep bluey purpley grey for the NaCl. We're then told in part A that we've got 1.5 moles of NO that are mixed with 1 mole of Cl2, and that the mixture is left to reach equilibrium at a given temperature. The equilibrium mixture was then found to contain 0.350 moles of the NaCl. We have to then calculate the moles of the NO and the moles of the Cl2 in that same equilibrium mixture. Now, I'm not sure how you will know this type of table by. Some of my former students call this an ICE table. I've always done it as initial moles, reacting moles, and then equilibrium moles. Some people do it as initial moles, change in moles, then equilibrium moles. Some people I've also heard refer to it as a SU table, so start, then used, then equilibrium. Either way, doesn't really matter what we call those row headers. What's important is that we understand that we're starting only with the reactants here, and I know that because we're not told any information to say that we have some of the NaCl at the beginning. So we're starting with our reactants. They will react to make the NaCl product in the forward reaction, and then eventually the equilibrium will be established as the NaCl decomposes back into the gases, and then we get to a point where both reactions are occurring at the same rate and the concentrations of reactants and products remains constant. So if you're not told that you're starting with any of the product, we have to assume it's 0, and then I've copied in from the question that we're starting with 1.5 moles of the NO, 1 mole of the Cl2, and then at equilibrium we end up having 0.350 moles of the NaCl. Now, you always will be able to work out this middle row, which I've called the reacting moles, for one substance in the reversible reaction. In this instance, it's for the product. So if we started with no moles, and we now know we've got 0.350 moles at equilibrium for the NaCl, then that means we have to have made 0.350 moles of the product as this reaction was getting to equilibrium. Using then the ratio from the balanced chemical equation, so we've got 2 moles of the NO with 1 chlorine to make 2 moles of the NaCl, we can then say, okay, as the NO and the NaCl are in a 2:2, i.e. a 1:1 ratio, that means we have to have lost 0.350 moles of the NO from the initial moles that we had to start with. So the equilibrium moles of that will be 1.15, because 1.50 take away 0.350 gives me 1.15 moles of the NO at equilibrium. The NaCl and the Cl2 are in a 2:1 ratio. So instead of losing the exact same amount, we would only be losing half of the Cl2. So that's 0.175, and then the equilibrium moles again worked out by doing the initial moles of 1, take away what's been reacted away in getting to equilibrium, the 0.175 to leave me with 0.825. So the reactant moles will always be decreasing because they're reacting together to make some of the product which we don't originally have, and thus the products will always be made. And there's our equilibrium moles for all three of those substances. Now, usually we won't then be using these numbers in the later question. So it says in part C, as we'll come to in a second, a different equilibrium mixture. So please don't get caught up with using these numbers in this next question. It's very unusual for them to carry that forward, and I presume that's because if students get this bit wrong, then they're going to be finding this next bit quite tricky. So they give you new numbers to work with here. On to part B, we're asked to give an expression for the equilibrium constant Kc. So all equilibrium constants, Kc, Kp, Ka, Kw, are always written by having the products over the reactants. And because we've got Kc, where the little c stands for concentration, we're going to have the concentration of the product, which is the NaCl, over the concentration of the reactants. And from our balanced chemical equation, those balancing numbers become the powers that we see after the NaCl and the NO. We could write Cl2 to the power of 1, but across all sorts of chemistry concepts, we don't write to the power of 1. We don't say we've got 1 mole of Cl2 in our equation. We make that assumption. So that would be my Kc expression. Now we're going to need that in part C because we are being asked to determine the amount in moles of the NaCl. So we've been given a value for Kc here, which is 1.32 times 10 to the minus 2. We've also been given the new values for the equilibrium moles of the NO and the Cl2, and then we've been given a volume because these obviously need to be concentrations. So again, do not make the mistake of using the equilibrium moles unless you have the same number of moles on both sides of the equation, which we don't. We've got 3 moles of reactants and 2 moles of products. So we need concentrations, and that's why they've given us a volume, albeit in the wrong units. Volume should be in decimeters cubed because the units for concentration are moles per decimeter cubed. So the first thing that I did was work out the concentrations of the 2 reactants. So doing the equilibrium moles provided divided by the volume in decimeters cubed, and I did that for the Cl2 as well. Then I subbed in the numbers that I knew, so my Kc value was equal to the concentration of the NaCl squared divided by the concentration of the NO squared times the concentration of the Cl2. Now, in order to get information about the NaCl, I need to remove these numbers from the bottom of the fraction. So I times those together, then moved them up here and times them by the value for Kc. And that would give me the value for my NaCl concentration squared. So then when I worked out that answer of 8.53 times 10 to the minus 3, I then needed to square root that to just get the concentration of the NaCl, which came out as 0.0924 moles per decimeter cubed. Now the question is asking for the amount in moles, and so many students will get to that point and stop because they are quite happy that they've got that far through this calculation. They feel they've done enough for the 4 marks at this point. They haven't read the question properly, whatever reason it might be. We have to come back and check, have they asked us for the equilibrium concentration of the NaCl? The answer is no. They've asked us for the amount in moles, so we have to then remember to convert between the equilibrium concentration and the equilibrium moles. So if we've got concentration and we've got the volume, we can easily work out the moles by doing concentration times volume, and that is then our final answer, the 0.0739. That for me is one of the harder Kc questions because of the rearrangement. But hopefully, having seen me do that, you feel a little bit more confident perhaps in being able to give that a go should you come across a similar question in the future. Now, as always, if anybody has any questions about any part of this question or has a different Kc question that they'd like me to have a look at with them, please do send it over to me. Please do ask any questions that you have in the comments, or again, send me an email. Hopefully that's been really beneficial, guys. Thank you so much for watching.